Hyper-V gives us many ways and features to create, configure, and control storage for our virtual machines. So in this nugget, we're going to jump right into the virtual lab and learn how to provide our virtual machines with the storage they need to support their workloads. We'll talk about VHDs and VHDXs, shared VHDXs, and the new VHD sets. We'll also talk about differencing disks and the many use cases that they provide, pass-through disks to provide our VMs with exclusive access to physical disks in the host machine, and storage quality of service, which is a feature that allows us to control the minimum and maximum amount of IOPS that our VHDs can consume from the disk that they live on. Let's do it. So I've already logged into our remote administration machine at MinNug. This is where we'll be performing all of our work remotely administering our Hyper-V host. Now let's begin in the GUI, and then we'll make our way over to PowerShell. So let's get right into Hyper-V Manager here. I'm going to right-click on the Start button, head up to Run, and hit OK here, which will launch virt mgmt.msc, the shortcut here to get in to Hyper-V Manager. So we're going to be configuring storage here for both GUI-NUG and CoreNUG on HV1NUG. We'll work with GUI-NUG here using our graphical tools, and we'll work with CoreNUG using purely PowerShell. Keep in mind, though, all of this also applies to our Linux machines over on HV2NUG, so feel free to practice on those as well. Now, there's a couple of ways that we can create VHDs and VHDXs. We can do it in the settings for a VM, which will automatically attach it to that VM for us, or we can do it outside of our VM here in Hyper-V Manager up here at the host level. So we can hit this new button, and we can choose New Hard Disk. This will just create the disk with all of the properties that we specify here, and then we will still need to go into the VM and attach it to the proper hard drive and controller of that VM. Let's do this one first, and then I'll show you how we can do it all in one shot at the VM level. Let's go ahead and click past the Before You Begin screen here. And the next screen, we're going to choose our disk format. We talked about the differences between VHD and VHDX in the past. We're going to go ahead and choose VHDX here, and we'll also talk about VHD set here soon. So I'm going to go ahead and choose next here to choose VHDX. We'll stick with dynamically expanding here. Just keep in mind, if you choose VHD, it will default to fixed size, and we'll also cover differencing disks here in a little bit as well. So we'll stick with the default and hit next, and now we need to specify our name and our location. I'm going to call this one GUI-NUG_data2. We already have an existing disk that we attached in a previous nugget to this machine. So this will be the second data disk that we're going to be attaching to this machine. It'll pick up our default location there. We'll go ahead and hit next, and now we can configure it. And since this is a dynamically expanding disk, I'm going to go ahead and give it 100 gigabytes. Also notice that we can copy the contents of a physical disk to this disk, or copy the contents of an existing VHDX to this one. So we're good here. We're creating a brand new blank VHDX, dynamically expanding up to 100 gigabytes in size. We'll go ahead and hit next and finish. And that's it. Now, that just created that empty disk and put it on the hard drive. That's it. It's not attached to anything yet. So the next step then is to attach it to a machine, and we're going to do that against GUI-NUG here. So let's give GUI-NUG a right click, head into Settings, and head down here to SCSI Controller. Now, keep in mind, we could add another SCSI controller to this, which we will do when we get into pass-through disks. But a SCSI controller can have up to 64 devices attached to it. So we're good piggybacking on top of our existing one. So once we choose our controller, we need to choose what we want to add to it. We're going to add a hard drive, so we'll go ahead and hit Add there. And now, at this point, we could browse, which is what we're going to do since we created this VHDX outside of our VM, or you can click New, and this will actually just launch right into the same exact wizard that we were in a second ago here, and then attach it to this drive on this SCSI controller. So that'll just save you an extra step. If you know you're creating a virtual hard disk for a VM, you can just do it through settings and it'll automatically attach it there for you. Since we already created it, I'm going to cancel out of that and hit the Browse button. This should plant us right into that default location, and if we scroll down, we should see that disk that we just created. There it is. If I hit Open, it is now attached to this machine. So at this point, if there's anything you want to change, you can hit the Edit button here, and this will walk us through modifying this VHD. We'll talk about how to do this here in a future nugget. And also, you can inspect it, so you can see what its current properties are. And this is going to be really useful when we get into differencing disks, so we can see the chain and what its parent disk is. So we'll get back into that here in a second. But this all looks good. Also notice here, the location it's going to use on that SCSI controller is 2, which is actually 3 because this is a 0-based index. So you can see 0 is our boot disk, 1 is our data 1 disk, and 2 is the new disk that we just created. This will go all the way up to 63, which again gives us support for 64 devices attached to this controller. So this looks great. At this point, we can hit OK or Apply, and that will save our changes. And now if we were to fire up GUI-NUG and log in and go into Disk Management or Server Manager, we could initialize this disk, partition it, and format it, and then we can use it. Now let's also talk about storage quality of service while we're here. Notice that each one of these VHDXs has an expand collapse button next to it. If we were to expand them, you will notice a quality of service node. This allows us to place a floor and a ceiling on the amount of IOPS that this disk either requires or can consume. Now the reason this feature exists and why it's important is because a lot of our virtual hard disks are going to be living on the same underlying physical disk and competing for those IOPS. So if we don't enable QoS, what could happen is a workload on a specific disk could run away with all the IOPS. And that will monopolize that disk and impede the performance of any other disk and any other VMs that are associated with those disks. Now, enabling storage QoS is a piece of cake, right? You put a checkbox here and you enter your minimum, maximum, or both for each one of your disks. The tricky part is figuring out what these values should be. And this is where resource metering can really come in handy. You can turn it on for your disks on your VM and then either simulate workloads or run actual workloads and let it gather those statistics, and you have all kinds of great IOPS statistics, minimum, maximum, averages, normalized IOPS, and that will give you a good idea of the kind of IOPS that each drive will need to support their workloads. So how about we specify a maximum of 100 IOPS here for our new disk? Now it's nice that we can get granular and do this for all of our disks, but it can also be a management nightmare to manually do this for all of your disks for all of your VMs. So this is where this policy comes into play, and you can only configure this using PowerShell, but it's very simple to do. You can create a new storage QoS policy, and in that policy specify your minimum and maximum, and then you can assign that policy based on its ID en masse to all of your disks. So it's a great way to keep it consistent and even for a specific VM or even all of your VMs. Or if you have different ones, you can create multiple policies and apply that to specific workloads across the disks in your VMs. All right, moving on here, let's talk about shared VHDXs as well as VHD sets. Let's click on our SCSI controller here and choose shared drive. And let's go ahead and hit add. That will add a new shared drive to this controller. Now, once we hit the new button here, it's going to launch us into a wizard. Very similar wizard, except when we choose next here, we have two choices, VHDX and VHD set. Now, before we dig into the differences between these, let's talk about what shared storage means in Hyper-V. This is used in the context of guest failover clusters, where we have multiple virtual machines with the same application installed on them, all pointing to the same shared storage, which is a very common thing to do for things like scale-out file servers, which we'll look at down the road in this course, as well as things like SQL Server. So we would stand up identical virtual machines with the same applications and services installed on them, add them into a failover cluster, and hook them up to shared storage. Now, prior to Server 2012, we had to break through the virtualization layer to access our physical shared storage, or we created virtual disks on top of things like iSCSI or virtual fiber channel, which was all very complex, difficult, and time-consuming. Server 2012 brought along with it shared VHDXs, and these were fantastic because they simplified everything. We didn't have to worry about breaking through the virtualization layer and hooking up to complex shared storage. We didn't have to worry about things like iSCSI. We can simply create a shared VHDX and hook it up to all the VMs in our failover cluster. The only downside, though, is it did have some limitations. There was no host level backup, no online resizing of our disks, and no Hyper-V replica support. And this is where VHD sets come into play. These get rid of all the limitations that we have with shared VHDXs, almost all of them. We can now perform host level backups. We can do online dynamic resize, and it has support for Hyper-V replica. The only thing we can't do yet with VHD sets is live migration and checkpoints. The other big difference between these is that a shared VHDX uses the standard VHDX extension, and we hook these directly up to our clustered VMs. A VHD set actually creates two files. One is a VHDS. This is what we hook directly up to our clustered VMs. And then a backing file where all the data is stored is an AVHDX. So everything goes through the VHDX and gets stored inside of the AVHDX. So let's go ahead and create ourselves a VHD set here. I'm going to go ahead and hit next. And now for both of these, it's just like creating a standard disk, right? We're going to choose if we want fixed or dynamically expanding. I'll choose dynamically expanding. We give it a name here. I'm just going to call this one, how about cluster data? Notice we have a .vhds format here. We'll store it in that location. Actually, let's just store it right in the root of the V drive. There we go. We'll choose next, and now we can configure the disk. Let's also make this one 100 gigabytes. We'll hit next here and finish, and we're done. Now, this isn't going to work for us right now. If we try to hit apply here, it's going to yell at us and say, sorry, can't do it because this needs to be on a cluster shared volume, a CSV. And we will actually do that down the road when we get into failover clustering. Notice here that this is going to say the storage where the virtual hard disk is located does not support virtual hard disk sharing. So again, we'll get into that down the road, but I just wanted to show you how to create one and the differences between them. And also, if you want to look at them on disk here, let's browse right over to HV1NUG, over to the root of the V volume, and there is the VHDS. So if we did have multiple machines in a cluster and this was living on a CSV, we could point all of those machines to this VHDS file. And here is where the data will get stored then in the AVHDX. So let's go ahead and hit the remove button here to get rid of it. There it goes. And now let's move in to pass-through disks. And we're going to need a new SCSI controller for our pass-through disk. So if we head up here to add hardware and choose SCSI controller and hit add, now we'll have a brand new controller and we can add a new hard drive. I'm going to hit add here and notice right now that physical hard disk is grayed out. And that's because while we do have a disk available to us over on HV1NUG, it's currently uninitialized. And your disks need to be initialized, but in an offline state, as the information bubble lets us know here. Now, before we go do this, I want to mention one thing. In the real world, only use pass-through disks if you absolutely have to, because we lose all the benefits we get from virtual hard disks, and we miss out on some of the greatest features in Hyper-V, such as Hyper-V replica, checkpoints, and live migrations. Also, portability is impossible, and backups are extremely difficult. All right, with that said, let's head over to HV1NUG and get that physical disk ready to go. So we're on our Hyper-V host here, HV1NUG. I'm just going to do this through Server Manager. You can also use Disk Management to do this as well. But once Server Manager loads up here and we get access to our File and Storage Services node in the left, we're going to go ahead and choose Disks, and we should have an unknown, uninitialized disk right here. There it is. So I'm going to right-click on this, and we're going to go ahead and initialize it. So we're going to say, yep, we want to initialize this as a GPT disk, no problem. And then we're going to right-click on it, and we're going to take it offline and hit yes. And there we go. That disk is now ready to go. Let's head back over to AdminNUG. And now, in order to pick this up, we're actually going to need to close out of settings here. So I'm going to go ahead and hit apply to apply all these changes. That'll keep everything the way it is. Hit OK. And now let's head back into the settings. Choose our hard drive down there, and look at this. Now we can choose our physical disk. There it is. We hit apply. And now we've just passed through a physical disk from our Hyper-V host into this VM. All right, moving on. Let's talk about differencing disks. I'm going to go ahead and close out of settings here for GUI-NUG. And let's hit the new button for our Hyper-V host here and choose hard disk. We're going to create a new disk here. I'm going to go ahead and choose next. This will be a VHDX format. Our disk type here, though, is going to be differencing. Now, differencing disks is probably one of my most used features in Hyper-V. I live by these things daily, especially here in our virtual lab. They allow us to create parent-child relationships where those changes are preserved on the parent and isolated on the child. In fact, let me give you a good real-world use case for how to use differencing disks. This is very similar to how we use them here in our lab environment. Well, let's say that you needed to stand up 10 VMs, and all 10 of those VMs were going to run Server 2016, and all a little bit different, right? They all have different roles and services. Would you rather install Server 2016 10 different times, or install it once and reference that parent image with the differences stored on those differencing disks? I already know the answer to that question, and here's how you could do it. We would start with a base disk, and we'll call this VMB for base. On that disk, we'll install Server 2016, customize the environment, get it exactly how we needed it. Now, let's say it's time to bring up VM1. What we could do is create a differencing disk and reference our base disk here as its parent disk, and we'll call this VM1. Now, VM1, when we fire it up, we'll already have an operating system because of the parent disk, and then any changes we make on VM1 will be isolated to its differencing disk. Let's say we needed VM2. Well, we could do the same thing. We could bring up a differencing disk, reference this as the parent disk. We'll call this VM2. Same thing. It already has an operating system when we fire it up, but any changes we make, right? Maybe we add different roles and services onto here that we did on VM1. Those changes are isolated to its disk. Now, let's say that VM3 is very similar to VM1. Maybe we installed the file server role here onto VM1, and we need another file server. Well, what we could do is create a differencing disk, reference VM1 as the parent disk, which has our base image as its parent disk, and call this one VM3. Now, VM3 starts with everything VM1 had and everything our base image has, and everything we do on it will be isolated to its differencing disk. So differencing disks bring us a ton of benefits. In our example there, we saved a ton of storage because we only had to install the operating system once, and a lot of time because we only had to install the operating system once. But it can also really help out when you need to test deployments or test updates, right? Just add a differencing disk, make your changes, and then run your test to see if everything works. If it doesn't, well, just blow away the differencing disk or try again with a new one. So let's do this. Let's say that for GUINUG, we want to preserve its current state. We want to install a new roller feature and test it out. And we want to isolate that to a differencing disk. Just in case anything goes wrong, we can roll back. So what we're going to do here is choose differencing and hit next. This is where we're specifying the name and location of the differencing disk itself. So if we were going to create a maybe GUI2 NUG, we could call this GUI2-NUG here and use GUINUG as our base. But what we're going to do here is call this GUINUG underscore diff1, just like so. We'll use the same location we've been using and hit next. Now is where we choose the parent for this differencing disk. So we're going to browse here and just choose GUINUG's boot disk right there. Hit open, hit next, and finish. And that's it. We've created a differencing disk. Now what we could do is spin up another VM, or we could modify this VM right here. So we could right click, choose settings. We'll head down here to GUINUG's boot disk, and we'll just browse and specify GUINUG's diff1. There it is. Hit open and hit OK. And now if we were to fire this up and go in and make changes, all of those changes will go to that disk. GUINUG's original boot disk will be completely preserved. So those are diff disks. Again, use them wherever possible. They'll save you time, they'll save you headaches, and even potentially save you on storage. And by the way, this is where the inspect disks function comes in very handy. You can see this on the settings page for your disks, or right here at the host level. You can hit it and browse to any disk. And if we browse down here to our diff1 and hit open, you will see the inspect parent button. And if you click on that, it'll open up the property pages for the parent. Now, if this parent had a parent, you can hit it again to understand the chain, the parent-child relationships that make up your diff disks. All right, let's do everything we just did, only against CoreNUG and entirely using PowerShell. So I'm going to go ahead and launch File Explorer down there from the taskbar, head over to our Nugget Lab directory, right-click on pscommands.ps1, and fire it up in the ISE. So first things first, let's enter a session over there on HV1NUG, our Hyper-V host. First thing we're going to do then is create a brand new VHDX. We've looked at this in the past. Very easy to do. New VHD, specify your path, your size. If it's fixed or dynamic, we're going to choose dynamic. So same thing here. We'll call this one data2.vhdx. There we go. We created a new VHD over there on HV1NUG. Now what we can do is attach it to our existing controller. And remember here, if we head back to the GUI, just to give you an idea of what this looks like from a graphical perspective, and go into the settings here for CoreNUG, notice that we have one SCSI controller. It's at the location 0 since it's the only SCSI controller in their index base. And we're going to look to add a drive here into the third position, which is actually technically the second since we are 0 base. So that's why we're referencing that here in our PowerShell script. We're saying controller type SCSI controller number 0, and the location where this disk is going to go here is 2. So let's go ahead and execute that. And when that's done, we can head back into Hyper-V Manager here, back into the settings for CoreNUG, and we should see that disk is now attached. There it is. Back in the ISE, we can configure storage QoS using the set VM hard disk drive command. And again, just reference the proper controller location, and then we can set the minimum and maximum IOPS. If we go ahead and give that a run and head back here to Hyper-V Manager and into the settings for CoreNUG, we should see for quality of service of our CoreNUG underscore data2 VHDX that it's now enabled and our IOPS value specified. Cool. Next up, creating a pass-through disk. We're going to add a SCSI controller to our CoreNUG machine. Let's go ahead and do that first. And now we use the same commandlet as adding in a VHD to a machine. The big difference here is we're not specifying a path. We're specifying a physical disk number. On HV1NUG, 0 is our boot disk and 1 is that data disk that we were working with. So this should add that physical disk as a pass-through disk to this VM. And now we should actually see that again if we go into the settings of CoreNUG. There's our new SCSI controller, and there it is, pointing to that physical hard disk. Now, right now, both of these machines are pointing to that pass-through disk. So if we were to start these up both right now, whichever one started first would get access to it, and the other one wouldn't start. So don't attach multiple VMs to the same physical disk. All right, back into the PowerShell ISE here. Creating a VHD set is very similar to creating a regular old VHDX. The big difference is the extension, and that's it. So this will give us the exact same result we did previously through the wizard. and it'll even create the underlying AVHDX. The last thing we're going to look at here is how to create a diff disk using PowerShell. Once again, the new VHD command line. Get familiar with this command line. It's versatile, as you can see here. You can do quite a bit with it. But to create a differencing disk, we specify the path to our brand new differencing disk and the path to its parent, and also specify the differencing flag. But notice this time we're creating another disk in that chain. So diff2's parent is actually going to be diff1, whose parent is GUINUG's boot disk. So if we execute this, that's going to go ahead and create it. And now if we were to attach this to a machine or modify GUINUG and modify the boot disk to hit this machine, it'll have everything that GUINUG has, everything diff1 has, and all the changes we make will then be isolated to this diff2 disk. And that is how we can create and configure storage for our virtual machines in Hyper-V. I hope this has been informative for you, and I'd like to thank you for viewing.